Okay, hello, welcome to my channel. My name is Silo Arch, and in this video we want to find the integral of this function. Okay, so the function is the natural logarithm of 1 plus the tangent of x, and we have to integrate this from 0 to pi over 4. Okay, so we're going to be using this tool right here. This is in fact a basic rule of integration when we have a definite integral, okay, with the bounds of integrations as numbers. So let's assume that this function, little function f of t, is integrable from on the closed interval a to b. Okay, good. And if that is the case, then these are the same. Notice that the argument here t has been replaced with a plus b minus t. That is the sum of the bounds of integration. Then we subtract t from that. So let's just sketch the proof for you to see how this works. So let me just put it down here. Good. So we're going to start off with the leftmost, the left integral, which is the integral from a to b of f of t dt. Good. Okay, so what I'm going to do here is u sub. I'm going to say let u b. Well, I notice we want to have something like this, a plus b minus t. So where the bounds of integration here are just a and b, so we're going to add them together, and then we'll subtract the independence variable from that. Good. So let's differentiate this to see what we have. When we differentiate u with respect to t, we're going to get negative 1. That would mean that du dt is negative 1, so that du is negative dt. That's built into the fact that a and b are just real numbers. Okay. Well, let's just say constants, but real numbers are enough for us for this level. All right. Okay, let's see what we have. Well, in this case, I'm going to write the integral as the integral. Well, notice for the bounds of integration, when you notice that t starts from a to b. So when t is a, what is u? So when t is a, u will be b. Okay, u is b when t is a, and then when t is b, u is a. Good. So this gives us the integral of this function. Well, this function, we're going to write the function in terms of u, because we are doing a change of variable from t variable to the u variable. Okay, so notice that this is t right here. T is the same thing as a plus b minus u. So I'm going to rewrite that, a plus b minus u, and that is just by solving for u using this equation. Okay, so the dt becomes negative du by this equation. So let me just put the du right here. Maybe I can put the negative sign out front. Okay, so we're going to use this negative sign to switch the bounds of integration. That will be the integral from a to b of f of a plus b minus u, and then the du is right here. Alright, but notice that we're doing a definite integral. In other words, the bounds of the variable here we're integrating over is just a dummy variable. That is to say, we can change it from any letter to any letter. The value of the integral stays the same, because of course this right here, they are just numbers. Alright, so that means we're going to have this to be the integral from a to b of f of a plus b minus u. But even if I change it to minus t, you get the same value, because like I said, these variables, when we use variables in indefinite integration where the bounds are real numbers, the variables are just dummy variables, and that's exactly what we have. So in fact, you look at the extreme right hand side, then the extreme left hand side, that satisfies with the tool. So we're going to use that in evaluating that integral. All right, so let me just clean it board, and then we continue. We start off with this integral right here. Okay, now over to this, so we're just going to apply the tool. Okay, so in applying the tool, let's see what we get. Well, this will become the integral from 0 to pi over 4. So you notice that our a here is 0 and our b is pi over 4. Good. So this is the function that is the natural logarithm of 1 plus the tangent of x. But in place of x, we're going to replace it with that. But so notice that we're going to add a and b. That will be 0 plus pi over 4, which is just pi over 4. So we have here pi over 4. Okay, and then we're going to subtract the input, which originally was x. Sorry, it's x, not t. Okay, so I'm kind of like used to the t. So this is dx right here. So I'm going to skip this space. So this is going to be, well, let's see what we get. Okay, so looking at that, okay, so let's see what we can apply on that. Well, in here we have tangent of the difference of two angles. Okay, so by the multiple angle formula for the tangent, I can write this as tangent of pi over 4 minus tan x divided by 1 plus tan x times tan pi over 4. Okay, so this is 1 plus, well, you notice that tangent of pi over 4 is just 1. So I'm going to say 1 minus tangent of x. Okay, I divide that by, well, at the bottom we're going to have 1 plus tangent of x. Good. So that is by using the tangent of the difference of two angles. Okay, so you notice that pi over 4, tangent of pi over 4 is 1, and I've applied that right here. Okay, so let's see what we have. Well, in the natural logarithm, let me just add the two fractions. So this is the integral from 0 to pi over 4 of, well, when we add these two fractions, where here is seen as 1 over 1, we're going to have natural logarithm of, well, this and that will be 2. Okay, that will be 2 over 1 plus the tangent of x. 1 plus the tangent of x. So let's put the dx right here. Okay, so this gives us what? We're using the property of the natural logarithm. We're going to rewrite this as logarithm of 2 minus logarithm of the denominator. Okay, that's built into the laws of logarithms. So that will mean we're going to have 0 to pi over 4 of, maybe let's split this into 2 at the same time. That will be the natural logarithm of 2, and then I put the dx right here. Then minus, the minus is because of this division that is happening in the logarithm. Okay, that will be the integral from 0 to pi over 4 of the natural logarithm of the denominator, which is 1 plus the tangent of x. Good, and then we put the dx right there. Okay, so let's see what we have. Well, this right here is just a constant with respect to x. So integrating that from 0 to pi over 4, we'll just have pi over 4 times this constant. In other words, we're going to have pi over 4 times the natural logarithm of 2. We subtract, well, notice this. This right here is the same thing as the function we started with. Okay, so of course this is really nice. Let me just put it down, and then we're going to observe what we get from there. So this is 1 plus the tangent of x. And then we put the dx right here. Okay, so you notice that the left hand side, that is the extreme left hand side, that is the function, the integral from 0 to pi over 4 of the natural logarithm of 1 plus tangent of x. And that's exactly what we have right here, but except that it has a negative sign. So since the extreme left hand side and the extreme right hand side have the common terms, what we'll do is to add this to that, and then we divide both sides by 2. Okay, so this is what we'll do. Maybe let's give this a name. Let's call this integral I. Okay, good. So notice that this is also I. That tells us that I, which is what we have on the left hand side here, is equal to this thing right here, which is pi over 4 times the natural logarithm of 2, and then we subtract I from that. So let me just say subtract I from that. So our aim is to evaluate this integral, which we just called I. So what we'll do is to make I the subject of formula from this last equation. So doing that, that will be 2i when we move this to the left. Okay, that is by adding I to both sides, and then we have to divide by both sides by 2. So the integral will become I will be, well, we're going to divide this by 2, which that will be pi over 8, then the natural logarithm of 2. And that's exactly what we wanted. Where this I is the integral we started with. Okay, all right, thanks for watching. That's very nice, isn't it? Hope you enjoyed the video. Please share with your friends, and wait for our next video.